this. You got this. You're the wizard. You're a fireball throwing wizard. You're a hero, and you look great. You and this.
Hello everyone, welcome to this new video. So I have come with a very excellent concept today for this wizard concepts of mathematics playlist. So like we were dealing the chapter sequences and series, so some of the amazing concepts that are hidden in sequences and series is actually being taught by me. So in that sequence we are like I am uploading this lecture. So till now we have discussed a method of differences and its shortcut, which is the part 1. Like there are 2 shortcuts for method of differences. So one shortcut and its examples have been discussed in the previous video with the theory, and now here comes the shortcut part 2. So in this video I'll explain the shortcut part 2 and an example, so that we will get a clarity of what it what's the importance of this shortcut. And the third part is the second part is VN method. So in this video I'll only limit up to the teaching of limit up to the theory of VN method. I'll not be giving any examples in this video. I'll be teaching some examples in the next video, but right for now, like for this video, we'll only limit that to theory and some of the conclusions that can be adopted from the VN method. So let us start today's lecture. So it's method of differences shortcut part 2. So what's its importance is, so for example, like if there is a series something like T1 plus T2 plus so on plus Tn. Alright, so this is the series given to us, and now we are looking out for Sn. So basically this is Sn. Alright, so T1 plus T2 plus so on plus so on Tn. So I'll just write it here. So Sn is equal to T1 plus T2 plus so on plus Tn. Alright, and now the differences between this two, alright, differences between the, like these T1, T2, Tn are not in AP, not in GP or not in HP. If they are in some series, standard series like arithmetic series or geometric series or something like that, we could have used that formula itself to find the Sn, but they are not in any of them. So for finding the general value of Tn and Sn, we are doing this. So now the difference between T1 and T2 is represented by delta T1, and between T2 and T3 it is represented as delta T2, and between them T3 and T4 it's represented by T3, and so on. Alright, so finally we'll be ending up in the form Tn minus 1 because there are n terms, so the differences will be Tn minus 1. And now coming to the difference between these two, that comes out to be delta square T1, and between these two that comes out to be delta square T2, and so on, and between these two we get that to be delta square Tn minus 2 because there are n terms at the start. The differences would be n minus 1 and the second set of differences will be n minus 2. Okay, so this is known as first order difference, and this is known as second order difference, and this goes on. And now there will be a certain differences. Alright, so let us name that to be delta R T1, delta R T2, and so on, where every delta is 0. Okay, so delta per R T1, delta per R T2, so on, delta per R T something, like some terms you can like n minus suppose it doesn't matter basically. So at n minus 4 it comes out to be 0. Then we can find the value of Tn and Sn depending upon the value of R. Okay, depending upon the value of R. So I shall explain with an example basically, then you people get a clarity. Now if it is R, okay, at the point of R we are getting all the differences between all the differences to be 0, then the Tn can be written as n minus 1 C0 T1 plus n minus 2 C1 delta T1 plus n minus 3, sorry, this is yeah, okay, n minus 1 C0 C1, and this is actually n minus 1. I shall erase this, yeah. So n minus 1 C1 T2 plus n minus 1, this is I shall write from first so that you people can avoid a bit of confusion. So the Tn, the general, like this Tn, the Tn is actually written in this form: n minus 1 C0 T1 plus n minus 1 C1 delta T1 plus n minus 1 C2 delta square T1 plus so on. If at r point we are getting all these differences to be 0, then we can stop this in this way: n minus 1 Cr, n minus 1 Cr minus 1 delta power r minus 1 T1. Alright, so it all depends upon the value of r. So Tn can be evaluated in this way: n minus 1 C0 T1 plus n minus 1 delta T1 plus n minus 2 delta T2, n minus 1 C2 delta square T1 plus so on, n minus 1 Cr minus 1 delta bar r minus 1 T1. So this is how you will evaluate Tn. And now Sn, I'll write this in this space. And now Sn can be evaluated in this way: NC1 T1 plus NC2 delta T1 plus NC3 delta T1 plus so on, like delta square T1, okay, NC1 T1, NC2 delta T1 and NC3 delta square T1 plus so on, NCr delta power r T1. Alright, so this is the value of Sn. So this is how you calculate Sn, and in the Tn is this one. Tn is, you can just evaluate T1 in this way. So we'll deal an example so that we can get a clarity. So the term, like find the nth term and sum to n terms of the series 45 plus 71 plus 102 plus 138 plus 179 plus 225 plus so on. So we can just observe from this, like these are not in AP, these are not in GP, these are not in HP, of course. So we can just use the theorem, like the method of differential shortcut, to find this. So the differences between these two terms are 45 71, we get this to be 26, and this one we get that to be 31, and this one we get that to be 36, and this one we get that to be 41, and this one we get that to be 46, and so on. Again we can infer from this that like the differences are not 0, right? These are the first order differences and these are not 0. Now come to the second part. This is 5, this is 5, this is 5, this is 5, and so on. And now these are the second set of differences and these are also not 0. Now take the third set of differences: 0, 0, 0, and so on. So we can say that this is the third set, and let me write this as 3, r is equal to 3. Alright, so my r is equal to 3, and this set will be counted for the reference of r, because all the set of differences are 0 here, isn't it? So we will be using this thing to find the value of Tn and Sn. So what's the value of Tn? As told, n minus 1 C0 T1 plus n minus 1 C1 delta T1 plus n minus 1 C2 delta T2. I'll just stop here because I just need to write till r minus 1. Alright, and my r is 3 in this case, so 3 minus 1 is 2. So I need to stop here, okay, and this is not delta T2, sorry for mistakes. So delta square T1. Alright, so n minus 1 C0, and what is my T1? It is 45 plus n minus 1 C1. What is delta T1? Like the first set of difference in the set of first order differences, the first term of the first order differences. So it is 26 plus n minus 1 C2 delta square T1. In the second order differences, the first term against 5. Everything is dependent about the first term as well as the value of r. So n minus 1 C0 is nothing but 1, so 45 plus n minus 1 C1. N minus 1 C1 in the sense n minus 1 itself. So n minus 1 into 26, and this n minus 1 C2, it's n minus 1 into n minus 2 divided by 2 into 5. So I'll just move on to the next space, so I can get some space here, and that is 45 plus 26 of n minus 1 plus 5 of n minus 1 into n minus 2 divided by 2. So it's 45 plus 26n minus 26 plus 5 by 2 of n square, and this is a minus 3n plus 2. So I get 45 minus 26, which is equal to 19, plus 26n plus 5 by 2 n square minus 15n by 2 plus 5. So I get that to be 19 plus 5, 24, 26n minus 15n by 2, which is equal to 37n by 2, and this is 5 by 2 n square. Alright, so this is what I am gonna get. So we can just even check it like by putting various values. Okay, so put n is equal to I'll use a different ink. So put n is equal to 1, we get that t1 to be like, this is a general form of tn, right? So t1 will be 24 plus 37 by 2 plus yeah, this is 5 by 2. So we get that to be 24 plus 37 by 2 plus 5 by 2, 42 by 2, which is 21. So 21, which is equal to 45. So you can even check from the question that my first term is 45 and my second term is 71. So let us check for that also. So t2 is equal to 24 plus 37 into 2 by 2 plus 5 by 2 into 4. So I get that to be 24 plus 37 plus 10. So 37 plus 24, 61 plus 10 is equal to 71. So my t2 is also verified. So you can just check it in this way, like we are able to find the tn or not. And Sn can be even directly evaluated, like the tn that we got is 5n square by 2 plus 37n plus 24, right? So we can even find the value of Sn by just putting sigma. Sigma tn is equal to like 5 by 2 sigma n square plus 37 sigma n plus 24n. So we can even find the value of Sn in this way, or we can even find the value of Sn using the formula. So what's the formula that we know for Sn? So Sn, in case like we know this thing, so it's not needed for us to remember each and every formula. So that's the reason I'm telling you to just put sigma and find the Sn value. But still, to use the formula, like Sn is nc1 t1 nc1 t1 plus nc2 delta t1 plus nc3 delta t3 delta square t3. Alright, because why am I stopping at here is because we need to stop at ncr delta power r sorry, this is again a mistake from my side. Just a second. So nc yeah, fine, nc3 delta square t1. Alright, so nc1 t1 plus nc2 delta t1 plus nc3 delta square t1, and we need to stop at r. So plus till ncr delta power r t1 is what where we need to stop, and our r is 3, so we have stopped here like nc3 delta square t1. So you can just put the values of nc1 the value of t1, which is equal to 45, and into nc1 plus delta t1, which is equal to, I don't remember what's the delta t1, yeah, it's 26. So 26 into nc2 plus delta square t1. So delta square t1 in the sense the third set of differences, which is equal to 5. So plus 5 nc3. So you can even like evaluate this and check that this will be equal to this one. So because Sn will be the same, you can just verify like whether this expression is being equal to this or not. So this is how you use a method of differences concept. Very, very important and amazing concept of finding Tn and Sn for many of the series, which we think that it's not possible to find Sn and Tn just by evaluating the differences and putting it in the standard formula of Tn and Sn. So coming to the main the main topic of today's video, that is VN method. So before just entering into it, I just want to rectify here. This is NCR delta power r minus 1 t1. Alright, so this is the formula of Sn. So coming to the VN method, so VN method is basically to find the series, like to find the sum of the series basically. Sorry, there was a typo here. So to find the sum of the series. Okay, to find the sum of the series of the form a1 a2 so on ar plus a2 a3 so on ar plus 1 plus so on, plus here there is a plus here again, yeah, so plus an plus 1 so on an plus r minus 1. Like what are a1 a2 a3 and so on an? They are in AP actually. Alright, so they must be in AP, and then only we can use the VN method. And this is a one form, and the second form is 1 by a1 a2 so on ar plus 1 by a2 a3 so on ar plus 1 plus so on, plus 1 by an into an plus 1 into so on an plus r minus 1. So these are the like forms that we actually for which we can actually use VN method to calculate the Sn, like till sum of the n terms or till infinity, whatever may be the case, we can evaluate using VN method. So for the first form, so the first form is a1 a2 so on ar plus a2 a3 so on ar plus 1 and plus an plus 1 so on an plus r minus 1. This is the first form. And second form, 1 by a1 a2 so on ar plus 1 by a2 a3 so on ar minus ar plus 1 plus 1 by an plus 1 so on an plus r minus 1. So we shall look out for the general for the first form. I shall write the value of Tn and Sn for the first form, like how do you evaluate and find the value of Tn and Sn for the first form. So I shall write here with the use of purpling. So the first form is, let me write that to be Sn. So Sn is a1 a2 so on ar plus a2 a3 so on ar plus 1 plus so on an plus 1 plus an plus r minus 1. Alright, so this is our value of Sn. So how do we evaluate now? So my Tn from this expression is basically an plus 1, an plus 2 so on an plus r minus 2, an plus r minus 1. Alright, so this is my Tn from this expression, like this is the series that has been given to us, the sum that we need to evaluate, and from that this is my value of Tn. Now there is a another term that I should define, which is known as Vn. So Vn is defined as an into an plus 1 into an plus 2. So it's basically not into, it's not yeah, we can use into, but just for the pronunciation sake I am just using it. So an into n plus 1 into n plus 2 so on an plus r minus 2 an plus r minus 1 into an plus r. Okay, so we are just adding an extra term to the value of Tn, like we are just putting in an extra term, that is n plus r. Okay, so that is what we are multiplying to this and making it we are naming it as Vn. And now Vn minus 1, just this one. Okay, in place of n we are putting n minus 1, we get that to be an minus 1 an plus 1 so on an plus r minus 3 into an plus r minus 2 into an plus r minus 1. Alright, so in place of n we are just putting n minus 1. So in place of n you can just put n minus 1 and you can check that this is what we want to get. And now we'll just Vn is this, Vn minus 1 is this. Now we'll just subtract these two. Alright, we'll just subtract these two. So what do we get? Vn minus 1 is basically an plus 1, an plus 2 and so on an plus r minus 1 into, there's these are the total terms that are common, and these are uncommon terms now that I'll write in the bracket, that is an plus r minus an minus 1. Alright, these are the two terms that are not common in the, both Vn and Vn minus 1, and these are the terms which are common. And basically what is an into an plus 1 into an plus 2 into so on an plus r minus 1? This is Tn. Alright, so just put that there. So Tn into an plus r minus an minus 1. Alright, so this is what we want to get. And going to the next page. So, and because these are in AP, these are in AP, my an is a1 plus n minus 1 into d, isn't it, because these are in AP. So from the equation Vn minus 1 we get that to be equals to, I am just writing it down, Tn bracket a1 plus n plus r minus 1 into d minus a1 plus n minus 2 into d, and you can just cancel these two terms, like a1 gets cancelled, nd gets cancelled, rd will be left, and minus d and plus 2d, which is equal to plus 1d. So you will be remained with r plus 1 into d into n2. I hope you guys are understanding. So it is equal to Vn minus 1. So basically we have just put the value of an, which is a1 plus n minus 1 into d, and like depending upon like the values we have are a n plus r. So instead of n we put n plus r, and we have a the other term is a n minus 1. So instead of n we put n minus 1, and we evaluated this and we found this to be the simplified version, that is r plus 1 into d into n2 into tn. So my tn is basically 1 by r plus 1 into d into Vn minus 1. Alright, so this is my Tn. And how do you find Sn? You just need to put sigma to it. So sigma Tn, so which is equal to sigma Vn minus 1 divided by r plus 1 into d. Now if I put like n is equal to 1 to n is equal to n, alright, like if I put n is equal to 1 to n is what I need to evaluate. So I can just take this term constant, the denominator which is constant, which has nothing to do with n. So I will just take that out. So which is 1 by r plus 1 into d sigma n is equal to 1 to n Vn minus 1. So moving on to the next page, I can write this to be 1 by r plus 1 into d. So just put first n is equal to 1, we get that V1 minus V0, and now put n is equal to 2, we get V2 minus V1. Put n is equal to 3, we get V3 minus V2, and so on. When you put n is equal to n, we get Vn minus 1, right? So we just need to add here. So what are the terms that are cancelling? You can just see V1 gets cancelled, V2 gets cancelled, V3 gets cancelled, so on. This one and this one gets cancelled. So finally you will be remained with 1 by r plus 1 into d Vn minus V0. Alright, so this is what you are remained with, and this is the value of Sn. And now you can put Vn and 0, like we have the expression of Vn here. You can just put, like you can just put this whole term there, and V0 is basically you need to put 0 in the place of n. Alright, so when you put that, it's basically a0 is not like you can just put it and you can find that to be 0. Like see here, 1 by r plus 1 into d. So Vn is you can just put the value of Vn, that is an plus 1, so on, an plus r, and V0. So what's V0? V0 is when you put like in the place of n, like in the place of n you just need to put 0. So what's the value of V0 that you're going to get? That is a0, a1, a2, so on, a, like where is that, like the end. So here we gonna get that to be AR. Alright, so instead of like here this is the last term of this total Vn, so you just put n is equal to 0, you'll be ending up with AR. So A0 into A1 into A2 into so on AR. So that's the value of V0. So you can just substitute that here, minus A0, A1, so on AR. And what is D? D is basically the terms, like the difference between the terms. So it's 1 by r plus 1 into A2 minus A1 into an plus 1, so on, an plus r minus a0, a1, so on AR. So this is the value of Sn for the first form of the like for the first form you can find the value of Sn, and value of Tn is here. So this is the value of Tn. Alright, so this is how you evaluate for the first form, and from this I just wanted to make some conclusions. Here. Yeah. So the conclusions are, for the first one, first conclusion is, for r is equal to 2. Alright, for r is equal to 2, we get that to be, we can write this a1 a2 plus a2 a3 plus so on plus an plus 1 is basically equal to, so you can just put the values there, and instead of r you can just put 2 and you get that to be 1 by 3 of a2 minus a1 into an plus 1 an plus 2 minus a0 a1 a2. Alright, so this is what you want to get. And for r is equal to 2, for r, sorry, we have discussed r is equal to 2 just now. For r is equal to 3, for r is equal to 3, we write this to be a1 a2 a3 plus a2 a3 a4 plus so on an, I'll just minimize this here, plus an plus 1 an plus 2. Alright, so which is equal to 1 by 4 of a2 minus a1 into an plus 1 an plus 2 an plus 3 minus a0 a1 a2 a3. So this is what you want to get for r is equal to 3, and you can just make the conclusion from here in this way. So for the next form now, so the next form number 2, yeah, so form 2, so what's that basically, it's 1 by a1 a2 ar plus 1 by a2 a3 so on ar plus 1 plus so on plus 1 by an plus 1 so on an plus r minus 1. So this is the value for which we need to evaluate Tn and Sn. Alright, so starting with the point, like in the same way, this is the Sn, right, this is the Sn. So my Tn is 1 by an plus 1 an plus 2 so on an plus r minus 2 into an plus r minus 1. So this is my Tn, and now my Vn is, I will be defining the Vn as an plus 1 an plus 2 so on an plus r minus 2 an plus r minus 1. So this is my Vn, and what did I change from Tn to Vn is, I just left the first factor. Okay, I just left the first factor. What is the first factor here? The an. Okay, the value of an I just left it and I have written it in this way. Except the first term, I written every term. So that is like in the denominator. So that will be my Vn value, and Vn minus 1 is 1 by an plus 1 so on an plus r minus 3 into an plus r minus 2. Okay, just put n minus 1 in the place of n. Alright, this is the Vn, and you are putting n minus 1 in the place of n, so that we get an plus 1 so on. Every term will be like is just reduced by one part, so an plus r minus 2. So this is the value of Vn minus 1. So moving on to the next page. So my Vn minus 1 will be 1 by an plus 1 an plus 2 so on an plus r minus 2 an plus r minus 1 minus 1 by an plus 1 so on an plus r minus like this is one term is what like we are reducing, so an plus r minus 1 and an plus r minus 2. Alright, so many terms are like common. We can just take those common terms at one side. So 1 by an plus 1 an plus 1 an plus 2 so on, like yeah, 1 by an plus 1 n plus 2 plus so on till an plus r minus 1 we can take common, an plus r minus 1, and the thing that are remained is 1 by an plus 1 in the first yeah, an plus 1 is also covered in this. So basically what is remaining, then an plus 1 an plus 2 so on an plus r minus 1, and yeah, only term like in this the second bracket we will not get an plus r minus 1. So till an plus r minus 2 is only common, so into 1 by a n plus r minus 1 minus 1 by a n, right? Because in the second bracket we like in this first bracket we are not having any term a n plus r minus 2, alright, and in the second bracket we are not having the term we are not in, like in the first bracket we are not having the term a n, the missing term I'll just write here so that we can we cannot we need not confuse. Basically the missing term is a n here, and the missing term in this case is like a n plus r minus 1, a n plus r minus 2, yeah, this is basically a n plus r minus 3, alright, a n plus r minus 3. So the term that is missing here is a n plus r minus 1. So these are the terms that are missing. So we have taken everything common and we have written in this way, like 1 by a n. So I just need to rearrange this. So it's 1 by a n minus 1 by a n plus r minus 1. So this is what we have got now, and so on simplifying we get this to be a n plus r minus 1, like yeah, this is n plus r minus 1 is what we are taking common, and minus n plus r minus 1, yeah, okay, fine. So a n plus r minus 1 minus a n, alright, so minus a n divided by a n yeah, a n plus 1, a n plus 2, so on a n plus r minus 2, alright, and we have these terms which are here like a n and a n plus r minus 1, and there is a small error here, plus and minus, and this whole term the denominator is basically 1 by Tn, is like this is 1 by Tn, so we can just put that here. So it's a n minus a n plus r minus 1 divided by Tn, and which is equal to basically Vn minus Vn minus 1. So going into the next page, so what's the conclusion we got? Vn minus Vn minus 1 is Tn into an minus an plus r minus 1. Yeah, this is actually 1 by Tn, so 1 by Tn is Tn, so Tn into an plus an Tn an minus an plus r and minus r minus 1. So using the same thing, like because they are in AP, so Tn of a1 plus n minus 1 into d minus a1 plus n plus r minus 1 which is minus 2 into d. So basically which is equal to Tn of 1 minus r into d, which is equal to Vn minus 1. So we get that value of Tn to be Vn minus 1 divided by d of 1 minus r. So this is the value of Tn that we gonna get. And now Sn, the same thing, like Sn can be evaluated just by putting sigma. So Sn is equal to sigma Tn, which is equal to 1 by d of 1 minus r into sigma Vn minus 1. So from n is equal to 1 to n. So we can just evaluate that 1 by d of 1 minus r, the same thing, just put n is equal to 1, v1 minus v0 plus v2 minus v1 plus so on vn minus 1. So these two gets cancelled, and so on, this one gets cancelled. So finally we will be remained with Sn to be Vn minus V naught by d into 1 minus r. So this is the value of Sn. So this is the value of Sn. So we got the value of Tn, we got the value of Sn, and on further like putting the general variable, like the general terms values like Vn and V naught, we get this to be 1 by, and d value to be a2 minus a1, alright, 1 by a2 minus a1 into 1 minus r into 1 by what is Vn, an plus 1, an plus 2, so on an plus r minus 2, yeah, an plus r minus 2, an plus r minus 1 minus 1 by a1, a2, so on ar minus 2, ar minus 1. So this is the value of Sn. So I just put the general terms and I got this value. And now Yeah, so now we can just come to some conclusions in the same way for the form 1. How did we write the conclusion in the same way for this? So conclusions for r is equal to 2, okay, for r is equal to 2, we write this to be 1 by a1 a2 plus 1 by a2 a3 plus so on. 1 by an plus 1 is basically 1 by a2 minus a1 into 1 by a1 minus 1 by an plus 1. Alright, so you can just simplify this if you need it, or you can just put it in this way: 1 by a2 minus a1 into 1 by a1 minus 1 by an plus 1. And for r is equal to 3, we write this to be 1 by a1 a2 a3 plus 1 by a2 a3 a4 plus so on 1 by an plus 1 an plus 2, which is equal to 1 by 2 of a2 minus a1 into 1 by a1 a2 minus 1 by an plus 1 into an plus 2. So this is the value of for r is equal to 3. So in this way we can calculate Sn and Tn using Vn method for type 1, like for type 1 and the type 2. So the examples and all I will be taking in the next video, because we already exceeded the time limit. Like I generally put the video time limit to be 30 or 35 minutes. I don't teach more than that, so that it actually creates a disturbance in the student's mind. So because we have already exceeded the time limit, I just wanted to put those examples in the next video. So I hope you guys enjoyed it. The first concept is method of differential shortcut part 2. This is one of the amazing technique to find Tn and Sn for most of the series, and then Vn method to find like Sn and Tn of the series of the form, like in this way: a1 a2 ar plus a2 a3 so on ar plus 1, and 1 by a1 the denominator, like just putting in the denominator of in a fractional wise, and for that also we can find the T and Sn using Vn method. I hope you guys enjoyed it. Thank you for watching.